Hello, guys. My name is Desmond, and I welcome you to my lesson for today, where we will be looking at mathematics. So, ladies and gentlemen, please do allow me to say it is very much important that I say it is very, very much important because what I'm about to say, it's massively, massive. Hey, massively important, ladies and gentlemen, that I say a day without learning something new. It's a day wasted. By so saying, please, Chumi, please, 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 Pindi, please do make sure that by the end of each and every lesson that I conduct, you learn something new. Very, very much important, ladies and gentlemen, over there. So, as you have seen, I did send a question paper in the group, of which we will continue from where we left off from our last, from our last lesson. But before we start answering those questions, let me quickly take you through this type of a function called an exponential graph. I wish all the grade 12s could also join if they are in this classroom, because what I'm going to explain to you is very, very much important. And if you can understand everything that I'm going to explain, I'm telling you, you will not have challenges with understanding questions based on this type of a function. So I'm just going to give you guys a summary and say, if you remember, guys, you firstly start as a baby and then you grow to become a teenager, and then from there you grow to become an adult. So there are phases that you need to go through. So now let's quickly have a look at how an exponential graph looks like at a baby stage. So you are having y, which is equals to b to the exponent x. So this is an hello, I come back. I'll need someone to confirm if I'm audible, and again, if you can clearly see there. Can someone indicate if all is good?
All is good.
Okay. So I was saying, this is how an exponential graph looks like at a baby stage. So you can maybe assume that in grade 10, this is what they teach you. So now, when you get to grade 11 or at a teenage stage, it then becomes something that now looks like that. And you will realize that the difference between this stage and that stage, it's simply because here they've added the a value. So as we continue, you will understand the impact of that a value on exponential graph. So now, when you get to grade 12, even while you're still in grade 11, it seems like they will ask you questions based on a function at an adult stage. So that means you will be looking at y is equals to a b to the exponent x, and then they plus eq there. So it's more like when you are in grade 11, you should be understanding everything that is in that box. When you get to grade 12, you need to understand that, and that. So you are very much likely to be learning these while you are still in grade 11. So now let's start with the explanation. This is what happens, guys. This is what happens. Under exponential graphs, your B value will always be greater than 0. So that means at that stage, you will never have y which is equals to 0 to the exponent x, never. And most importantly, we say your B value will never be equals to 1. That is why we cross that equal sign there. We are saying you will never have something looking like y is equals to 1 to the exponent x. I hope you guys understand that. So that means the B value can be any value greater than 0. So that means B can still be 1 over 2, because 1 over 2 is greater than 0. It doesn't necessarily mean that it has to be 2, it has to be 5 or a bigger number. You can still have a fraction, maybe let's say 4 over 3, because this is 1 comma something, so it is still greater than 0. So just always remember that. So now let's quickly explain something. So if already they are saying your B value will always be greater than 0 and will never be equals to 1, that means that that B value can never be less than 0, meaning you can't have your B being -2, -1 over 2, -3, -4. It will never be a negative value. It will never be 0. It will never be 1. It will be greater than 0, but not equals to 1. So just always remember that. So it's not like this information will help you that much. You just need to be aware that when we are dealing with exponential, your B value will be greater than 0 and it will never be equals to 1. So that's something that you need to remember. So now let's start with important points. The first point says, when our B value is greater than 1, the y value increase, and the function is called a increasing function. It might not make sense, but it's going to make sense when I do this. So obviously we sketch a function on a Cartesian plane having the y and the x axis. So how does an increasing function looks like? Remember, guys, I'm only talking about that B value. I'm not yet talking about the A value and the Q value. I'm only talking about the B value. So make sure that before I move on to the A value, you fully understand all that you need to understand under that B value. So an increasing function looks like this. So when we sketch a function, we always start from the left. From the left towards the right. So can you see, starting from the left, am I increasing or decreasing when I draw that function in that direction? You can see it's increasing. It's increasing, it's increasing, it's increasing. The y value, it's increasing. So that means all the functions starting from the left increasing in that direction or increasing in that direction, it doesn't matter. So that means these are the functions having a B value which is greater than 1. So now let's move on to bullet number 2. That's when something might make sense. So bullet number 2, they say when this b value, it's actually between 0 and 1. So this thing, it means b is between 0 and 1. Remember, here we are saying b will be greater than 0 and it will not be equals to a 1. So maybe let me do a number line there so that it makes sense. So if this is 0 and this is 1, and then you have other values which are greater than 1 continuing in that direction. So what happens here is that you have your b which cannot be 0 and it cannot be 1. So that means our b value can actually be between 0 and 1. And we are saying when you have your b value being between 0 and 1, that's where you are having an increasing function. So that means we call this type of a function an increasing function. Why? Because you can see it's increasing in that direction. So now bullet number wait. Let me quickly make sure that I'm not doing vice versa. Yes, I notice I'm doing a vice versa. So let me quickly remove all of that because we started with bullet number 2. So this is bullet number 1. What I've just explained, it was actually for bullet number what is it? What I've explained is for bullet number 1. I will actually explain or re-explain for that bullet number 2. So we said if b is greater than 1. So that means that's when b is after 1 or any value after 1. That's where we say it has an increasing function. And then for this one where b is between those, this is increasing a function. So when b is between 0 and 1, meaning it's between there, that's when we have a decreasing function. How does a decreasing function look like? So that's where, remember, you start from left to right. So can you see the y value is decreasing. So that is what I mean when I say when b value is greater than 1. When you draw your function, you should expect that type of a shape. But if your b value is between 0 and 1, you should expect that type. And we call this type a decreasing function and that type an increasing function. Maybe before I go deep, let me just check if you guys understand what I've explained there regarding those two bullets. Does it make sense now? Are you sure you are not being confused by what I'm explaining there? I couldn't get that, Pindi. Is it a question?
Repeat again.
I couldn't hear Pindi, but I heard something from Matapel. So let's see. Maybe let me do it this way so that it's easy to understand. Let's say when b is greater than 1, increasing function. Yes, increasing function. How does an increasing function look like? So an increasing function, it means the y value increase. So that means the shape of a function is going to look like that. This is an increasing function. Then you say when b is between this is how you write between. When b is between 0 and 1, therefore we are having a decreasing function. How does a decreasing function look like? Can you see? You start drawing from left to right. So can you see that it's actually decreasing. So this is the shape of a function where you are having b being between 0 and 1. And then if your b is greater than 1, that's when you have an increasing function. Ngwana Major, does it make sense now? I couldn't hear that. Someone to confirm if that part makes sense. No response. I'm not sure if the message is still delivering. Guys, this part, does it make sense what I've just explained?
It makes sense.
Yes.
Okay. Okay. So now let me quickly move on to bullet number 3, which is something that you also need to be aware of. Under bullet number 3, remember, guys, these notes that I'm using are there in the library. I think as soon as this lesson is done, I'm going to post them in the group so that you can easily access these notes. I'm just thinking if no, let me not post them now because you won't be seeing where I'm explaining. So, bullet number 3, we talk about what is it? Maybe let's talk about that A value. Yes, because bullet number 3 actually jumps to Q, but let's talk about that A value. So this A value, it only influence the steepness. That's all the A value does. For example, on a Cartesian plane, if you have this type of a function, is it an increasing or a decreasing? It's an increasing function. So it has this slope. But for a function not to have that type of a slope, sometimes it could look like that, for example. The question is, what makes it to make a turn and take that direction? It's because of this A value. So you might find that the bigger the A value, the bigger the steepness or the slope. The smaller the A value, maybe whatever that you call, which is the opposite of steep, could be gentle. So I'm pretty much sure that you guys are having an idea of the impact of that A value. So for now, you don't need to worry that much about that. You just need to be aware that, okay, this is just a value that influences the steepness and nothing much. So it's not there to complicate your life. So again, regarding the A value, does it make sense to everyone?
Yes, sir.
Okay. And also, this A value, something that you need to be aware of. A value is actually the y-intercept. So we're going to say A value, it's actually the y-intercept. Intercept. It might not make sense to someone. Someone might be wondering, how is A the y-intercept? It only makes sense when you try to think about it this way. Let's say you are having y, which is equals to 2. Let's say maybe we are having a 2 also there to the exponent x. Can you see your A value in this case is 2, and then now your B value there, it is a 2. So this one, two things, the steepness, and again I'm saying it is the y-intercept. So you don't need to worry about the steepness because it's a shape that you only see as you plot. But most importantly, this A value, it is the y-intercept. How is it the y-intercept? Do you guys still remember that for you to calculate the y-intercept, you're going to say that's where x is equals to 0. I'm sure you guys remember that. So let's try to substitute there. Can you see? You're going to say 2 into 2 to the exponent 0. So you're having 2. What is this thing to the exponent 0? It's 1. So it's more like you're having 2 into 1. So what is 2 times 1? It's equals to 2. So that means your function, it's actually going to cut at that point there being a 2. So that's what I meant when I was saying this a value, it's actually your y-intercept. Okay, let's try another example. Someone thinks it only cuts at where y is equals to 1. Let's maybe try this one, where y is equals to, let's say 1 over 2 to the exponent x. Here comes a question. What is the a value for that function? Anyone who'd like to guess? What is the a value?
One.
100%. A value is an invisible 1. What is the b value for that function?
1/2.
100%, 1 over 2. So do you agree that since I've said a is the y-intercept, let's try to prove it. So that means for you to calculate the y-intercept, that's where x is equals to 0. So that means you're going to have y, which is equals to that invisible 1 into half to the exponent 0. So it's more like you're having 1 into, we know anything to the exponent 0 is a 1. So it's more like you're having 1 times 1, which is 1. So can you see, if you had to plot your function, then it means it was actually going to cut the y-axis at where y is equals to 1. But be careful of something. Be careful of something very much important. Can you see? Is your b value greater than 1 or between 0 and 1? That's where that information is important. If it's between 0 and 1, that means we said you must be having a decreasing function. But if b was greater than 1, that's where you have an increasing function. So that means the function that you're going to be having, it is not that type, but it is a decreasing function. Why? Because of that being between 0 and 1. I'm not sure. Does it make sense, guys, what I'm explaining there? Are you sure you understand the relationship between A and B at this point?
Sir, I don't understand the 1/0 smaller than p smaller than 1.
Okay. It's just that I removed that information. Maybe let me write it here so that I will bring it back from time to time. Let's maybe write it down as part of our notes. So we are saying let me get a different marker there. Very, very much important, guys. We're saying when a b is greater than 1, we call it increasing function. Increasing function, this is how it looks like. That's when it does that type of a shape. This is y-axis, this is x-axis. So when a b is between 0 and 1, we have a decreasing function. So the chumis, what might be confusing you is this thing, this thing, don't call it 0 less than b, 0 less than, say b is between 0 and 1. That's what is meant. If you are not able to interpret what that means, you will struggle to understand that. So what is a value which is between 0 and 1? It's normally a fraction. Maybe let's give an example there to say where we have b being greater than 1. That's if you have, for example, maybe let's say f of x is equals to 2 to the exponent x. Can you see? The b value is greater than 1. G of x is equals to 3 to the exponent x. What is it? Maybe k of x is equals to 4 to the exponent 3. H of x is equals to 5 to the exponent 3. Can you see? The b values are greater than 1. But in this case, where we say b is between 0 and 1, that's where you have a fraction as your b. So let's say, for example, you are having a f of x, they are going to say maybe 1 over 2 to the exponent x, or maybe h of x. Sometimes you may find is 3 over 2 to the exponent x. Maybe g of x, I think even a value like 3 over 5 to the exponent x, it is still between 0 and 1. Because if you do that, you might find that as a decimal is 0.35. Can you see this value is between 0 and 1? So the truth is, for you to fully understand it, do not call this thing 0 less than b less than 1. Always, if it's d there, it means d is between whatever that is, whatever that is. So how does a decreasing function look like? This is how, can you see? The y value, what does it do? Can you see that it goes down, meaning it decreases? It's going down, 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 down. So remember, now we are only talking about the b value. So when you talk about the a value influence the steepness. You might find that instead of it taking that route, maybe it's too steeper, and then it does something similar to that, or it is too gentle, it does something similar to that. This is because of the impact of that a value, and at the same time, this a value, it is that y-intercept there, based on that calculation that I did where we say x is equals to 0. And then also here, as a result of the a value, it could be steeper or it could be gentle. So that is the impact of the a value. And at the same time, that a value, it actually gives us the y-intercept there. I think take a screenshot if you can, and also can you guys give me feedback if it now makes some sense? Is it better now, the way in which I've done it?
Yes, sir.
Okay, so let me not remove or erase that. And then now, let's try to continue now to bullet number whatever. Let's say the next bullet. So now, under this type of functions, exponential, we have what we call an asymptote. So actually, Q is asymptote. Asymptote. So that means you guys now know the impact of A, you now know the impact of B. We are now on Q, and we're saying Q is the asymptote. So that means under exponential, we only have one asymptote, but under hyperbola, you have two asymptotes. Just always remember that. You only have asymptotes under exponential and hyperbola, but when it comes to parabola, it's what we call an axis of symmetry. Remember that. So Again, this Q value being the asymptotes, it tells us more about the vertical shift. Q, again, vertical shift. Just like on a straight line, we know that the C value, vertical shift, and the hyperbola is still letter Q, vertical shift, and the parabola is C, vertical shift, and the exponential is Q again, vertical shift. What does vertical shift mean? It means either up or down. If your Q is positive value, then it means it's an upward shift. If it's negative value, it means is a downward shift. Let me maybe give you guys an example, because sometimes a maths can be explained by use of words, but graphically or diagrammatically, that's when it can make some more sense. So let's see. So that means, for example, on your Cartesian plane, if you are given y is equals to, let's say, 2 to the exponent x, here comes a question. For this function, are we having a decreasing or an increasing function?
We are having an increasing function.
100%. So do you guys agree that since we are dealing with an exponential, we have an asymptote?
Yes, sir.
Yes.
Okay, 100%. We will always have an asymptote, but now what is the value of the asymptote in this case?
0.
100%. So that means our Q here, it is 0. How do we represent an equation of an asymptote, or how do we represent an asymptote? We represent it by a horizontal dotted line. Do you guys agree? I'm pretty much sure that you guys still remember that. So that means when you
Yes.
sketch, you are going to do that broken line where y is 0. That is why I'm doing it inside that x-axis. But because the line of the x-axis is a solid line, that is why with this type of a function, you won't physically see that dotted line, but always know that it is there as 0 and it is hidden by the solid line of the x-axis. And because it's an increasing function, that is why your teacher will say it just gets closer to the x-axis. It never touch, it never cross. But mathematically speaking, we are not saying it gets closer to the x-axis, but we say it gets closer to an asymptote, of which in this case you can't see that asymptote because it's hidden inside the x-axis. I'm not sure if what I'm explaining makes sense, Bantu Bagiti. Does it make sense, guys?
Yes, it
Yes.
does.
So, Molebo, my teacher used to say, this thing, erapalla le asymptote. I'm not sure if you know the word orapalla, Molebo, which means
Yes, yeah, Elise.
it gets closer and closer and closer, but it never touch, it never cross. Iyasondela bantu bakithi, iyasondela. So now the machumis, remember to mute your mic, honorable member. So now our asymptote is 0, is there, we have seen it. So maybe let's talk about the impact of A. What if this function, it was not 2 to the exponent that, but it was let's say 3 into 2 to the exponent x, or it could be written as 3 dot 2 to the exponent of x, or it could be written as 3 2 to the exponent x. Just know that this thing is not 32 to the exponent that. That is why they will use those brackets, because it ends up looking like it's the 2. So the impact of that is that this thing, it still has an asymptote of 0. But because of that a, it will then do something similar to that. Let's see. It will do something similar to that. Can you guys see that it is now becoming steeper? Which means for this one, our A value is that invisible 1 there. That is why it cuts at 1. But for this one, our A value, it is that 3 there. And also, because of that value again, it actually becomes steeper. That is why it looks something similar to that. Why? Because of the value being bigger. So maybe if here it wasn't 3, but it was a smaller value, let's say maybe if it was 1 over 2. Can you see 1 over 2? It's a value less than 1, or it's a little value. Remember, I'm not talking about the B value, but I'm talking about the A value. So that means, for example, it was going to cut there at half, and then it does something similar to that. Can you see the slope? It is not that steep for this one having a value of half. That is why it actually cuts the y-axis there at half, because we said that a value, it's actually what is it, y-intercept. Also, what I've explained there, does it make sense, guys?
Yes, it does.
Yes, sir.
100%. I'm very much happy that you guys are following. I'm just not sure if it's something that I'm missing, but I think let me quickly add this point to say, under exponential graphs, we also have what we call the range. Yes, what we call the range. I notice I'm running out of battery. I will need to quickly get my external power. So let's see. Now, for example, if you have um, a Cartesian plane there, it doesn't matter whether you have that or whether you have that. When we talk about the range, so the range, we just say y it's greater than something. So it's more like if we know that our asymptote is inside there, then we are going to say our y is greater than 0. It's more like we are saying our function, it's actually above 0. So that is the range, meaning it actually plays above that, because it never touch, it never cross. That is why we are not saying it's greater or equals to, but we're just saying it's greater than. Remember, this, I said you can interpret it as greater than, as above, or as bigger than. It all depends on the situation that you're facing. So in this case, we can't use the word greater than. We can maybe use above to say our function is actually above that asymptote. So if the asymptote now moves, let's say it is not at 0, but it is somewhere there, that means our function, it will always be above that, because it never touch, it never cross. So if there you are having 1, you might find that you're going to say the range, that's where y is greater than 1. If it was 2 there, 2. If it was 3 there, 3. So it's more like your range is dependent on your asymptote. I'm not sure, guys, if you got that part. I think when we start answering the questions, that's when it's going to make some perfect sense. But do you guys so far understand what I've explained there?
Yes, we do. But can I ask again? Can I ask again in regards to the range where
Yes.
our asymptotes are? If our asymptote is from the origin, we are going to
Mm.
say y above 0 from the origin. But
Yes.
when
Yes.
our asymptote starts from 2, we are going to
Yeah.
say y is greater than 2.
Yes. Yes, yes,
Okay, no,
yes,
I just
yes.
wanted.
Yes.
Okay, no, thank you.
Yes. So, hold on to that thought. Let's hope we come across a question which asks us to give the range, and then we'll put a stamp on it. Because on my notes, it's not clearly explained to that extent. But for now, let's hold on to that thought, and we will, or we might get to a question which says, what is the range? But one thing for sure, the range for now, know it as where your asymptote is, that same value, it is the value for your range, meaning your function, it actually ranges above your equation of asymptote. That is why you say y is above whatever the value of that. So now let's maybe move on to that question posted in the group and see how far we can go with that. I notice I'm on 7%. Let me maybe check if while I'll be looking at the Petri, you guys can quickly work it out. So I think you guys now understand that we've got 3 stages: that stage, that stage, and that stage. And the question that we're looking at is based at that stage. So, Pendi, can you see that for everything that you need to do, or that you do, you need to understand every component. Like now, I'm sure you understand the impact of A, you understand the impact of B, you understand the impact of Q. I'm telling you now that you might have done this at school or in class, and you might not have gone too deep into interpreting the meaning of those. And for you to understand that, it might take you a week or two. So it doesn't necessarily mean that you need to take long to understand something. You can just understand it within 30 minutes and you are confident. It all depends on how the information is being delivered, how you understand, and also to what extent it makes sense. You will now see that this question that we are about to do, it looks a bit scary, but it is not that much difficult or complicated. But obviously, examiners, they won't just make it easy. They will try to somehow try to be tricky, and you will notice how tricky examiners can be. Okay, this is what I'm going to do, guys. Question number 5.2.1. This is 5.2 where they say given. This is what we are given under 5.2. So 5.2.1 says determine the coordinates of the y-intercept of h. So they want you to determine the y-intercept. Remember that always when you do the y-intercept, that's where x is equals to 0. Always remember this. So in the meantime, guys, please calculate the y-intercept. I'm just going to quickly get my external power so that I don't lose that. So when I come back in less than a minute, I will need the y-intercept. Okay, are you guys done, or are you still calculating that side?
7. Well, our y-intercept is equals to 7.
someone is getting 7. Is it everyone who's getting 7? Moleboge, I'm now wondering if your answer is correct. How is it the case that you already got 7 and honorable members are still calculating there?
I don't know. Remember, when we are calculating the x value, we are only substituting to the equation that we are given. Just on the x value, we write 0, and then it gives us 7.
Mara Molebogeng, what's wena o crack wena ne? Hey, ha ke utlwisisi Molebogeng, mara o tla mpolella ka letsatsi le leng gore sentle o batlang fa o batlang fa Molebogeng, because it's either you quickly understand or you are able to quickly perform those questions. And now I'm wondering, isn't this person from Department of Education and doing those secretive inspections? Hey, Molebogeng, o sure a o le undercover? Hey, wena go
No, I can't.
itsege wena.
No, I'm not.
Honorable members, let's make sure to behave. There is an undercover amongst. Hey, Sibusiso Kouka, do you understand, honorable member? What are you getting there? As a maybe let me calculate. Let me see. You just say 4 into 2 to the exponent negative. Let's see, to the exponent negative 0 there, and then you close, then you plus 1. Hey, I knew it. Ngazile mina. Guys, what are you getting there? I'm getting an answer there.
Sorry, I thought we were doing the first one. Sorry.
Which one? Oh, no, I see. No, I see.
Okay. So, no, sorry.
No, I see. But your approach, it's 100%, because what I'm surprised at is the fact that you were able to notice that you don't really need to write all of that. You just punch on a calculator from that given equation, and then you get an answer. So maybe let me explain. I'm pretty much sure that it might not be Molebogeng who's not aware. I mean, you might find that it's not only Molebogeng who's not aware. So that 5.1, we did it, I think it was last week or on our previous lesson. So we did 5.1 up until 5.1.5, I think. So we are just continuing now. That's why we are not starting from the start. So that first part, the lesson is there, is recorded and is posted, so you can still catch up. But for now, we are moving on to this one. So what are you guys getting there when you punch all of that?
5.
5.
100%, we are getting 5. So that means with you doing that, they are going to give you a mark there and also a mark there. That's how you answer 5.2.1. Is it everyone who's happy there? I think that was a straightforward question. But now, this is something that I want you guys to be aware of, which is the tricky part about this question. What is A? What is B? What is Q? Yes, that's what you need to know every time when you're given an equation. What is A? What is B? What is Q? Anyone can tell.
1.
Our A value is 4. It's positive 4.
I think Matapel was saying something, but I couldn't hear that, honorable member. Okay, A value that. What is
Sir,
our B?
I think the B value is 2, sir.
B is 2.
And Q is 1. Positive 1.
Q is positive 1. So, Mzozozo, it is during these lessons where I'm not only interested in answering the questions, but these are the types of problems that your fellow learners will be having. So always remember, Bantu Bakiti, to say this thing, it's actually the same as equals to 4 into it's actually this thing. It's actually 2 to the exponent negative invisible 1 to the exponent x plus q being 1. So that means if you look at this, is b to the exponent x and not b to the exponent negative x. So that means this thing is the same as 4 into what is 2 to the exponent 1. If you punch it on a calculator, it's going to give you 1 over 2. So that means your b value is actually between 0 and 1. So this is how the simplified form of that looks like. I'm not sure if you guys understand what I've done there, because if you don't know this, it's going to be tricky for you to sketch, because you're going to say you need to have an increasing function, whereas it's not an increasing function based on this. Did that make sense, or does it need a re-explanation?
So please explain.
I think honorable member is requesting a re-explanation. So if they say g of x is equals to 3 into 2 to the exponent negative, let's say 4 to the exponent that may be minus 4. This thing, it's actually the same as 3. And then this thing, you have it as 4 to the exponent negative 2 to the exponent x. So it's more like the Mapindis. You remove whatever that is attached to x. It is actually the power of this thing. Then you further rewrite it as 3. That means this thing, 4 to the exponent negative 2. If you punch it on a calculator, it's more like 16 to the exponent negative 1, which is what? 1 over 16. So this thing is the same as 1 over 16 to the exponent x. Then you still have that minus 4. So that means where examiner can try to be tricky is this part of exponents. They play around that to confuse you. So if you don't know this, you are in a big trouble, because you won't be able to interpret that. I'm not sure. Does it still need a re-explanation with a different example? Or are you having some light nyana nyana there? Hey, I couldn't hear our undercover there. The undercover.
No, I just wanted to understand something. Our
Yeah.
B value in this equation, you are saying is equals to 4 over 2 to the exponent 1. Okay, exponent x, which is 1 plus 1. So our B value here in this case, because B value what equals to. So our B value, get this whole sum.
Wait, where are we? Wait, because I heard you mentioned values. I need to quickly rewrite. Which one are you referring to? This one? Is it this one? or this one?
I'm referring to that one, the top one, the 4 bracket 2 to the exponent negative x. So I'm referring to this
Okay.
one. I'm saying to you now, let's give them values. I want to understand. So you said we must tell you the A value, the B value, the Q value.
Yes.
So I'm now asking, I think I'm confused. What is our A value now?
Oh, okay. No, I see. Our A value is 4. Our B
Okay.
value is 1/2. Our C value or Q is 1. You
Okay.
remember, honorable member
No.
was saying is 2. So that's where the confusing part is. And if you say 2, it's more like you're going to have an increasing thing. Whereas examiner tried to be tricky and gave it in that manner, which means we are expecting possibly something looking similar to that. I'm not sure if it now makes sense, honorable members.
No, I'm now okay because I was confused. I was thinking, where is our A value? So now I understand.
Oh, okay. But this one of being given something to the power of negative value, does it make sense to everyone? Let me see. Leslie, does it make sense, honorable member?
Yes, sir.
Okay. Let me give a last example as a bonus, and you guys will tell me what is what. Maybe let's say f of x is equals to let me do this. What is our A value? What is our B value? What is our C or Q?
One. One. A not B.
Oh, A is 1. Okay. And then what is B?
Positive 3, sir.
Positive 3.
Positive, sir.
Positive 3.
Yes, sir.
And then Q.
B. Q.
I couldn't hear that. What is Q? Can someone try for the last time?
Q is equal to 0, sir.
Q is 0. There I agree. But where I don't agree is that B. It seems like that B is going to be hammering most of you guys. Let me explain it this way. How can we rewrite this thing such that it is whatever and X is just hanging there alone? That's if you write it this way. Can you guys agree? Then now, what is 3 to the exponent 2? Is it not 9? So that means our B value is 9. Our A value is 1 and then Q is 0 there. I'm not yet confident that you guys understand this B value. And that's where examiner is going to play around in order to confuse you. But does it make sense now what I've done there. So it means whatever that is attached to that, somehow you can work it out to know what your p value is. So does it make sense now? I think it does. I think it does. So we will try some different questions so that you are able to see. When you get to grade 12, it gets even more complicated because you might find that you have 2 to the exponent, whatever value, maybe they plus a 1 there. So we will also have to check how you work out or you go about that. So don't worry that much about knowing the exact value of b. It's not like they might simply say what is the b value, or try to work it out or rewrite it in that format to know what the b value is. The b value is there to just remind you of how the shape will look like. So here, something that I need to explain, I think I did not include this in the intro. If you remember, I said this tells us more about the vertical shift. So this means our equation of asymptote, it is now at where y is equals to 1 there. So because of this a value, the b value being between 0 and 1, b is half. That means we are going to have a decreasing shape. And can you see that decreasing shape? It is actually going to look like that. And then, Muleboge, can you notice something, honorable member? We said this a value, it tells us about the y card, but in this case our y-intercept, it won't be 4. Why is it not going to be 4? It is because it was 4 originally, but it shifted upwards by 1. That is why when you punched all of that, where here it was 0, you got 5. It's because it was cutting at 4, but it shifted by 1 unit upward. That is why there it is actually going to be 5. So it's more like actually the y-intercept, it's actually that a value and then being plused by that q value. So if the q value was 0 there, it was going to be more like it's 4 plus 0, which is equals to 4. But in terms of this, you don't need to worry that much. I just wanted to explain that the q value means a vertical shift upwards. If it was negative here, that would mean our equation of asymptote was going to be there, and then our function was going to do something maybe similar to that. Then it wasn't going to cut at 4, but it was going to cut at 4 minus 1, which is going to be 3, because it was supposed to cut at 4, but because of the downward shift, then it shifted downwards by 1, then it cuts at 3. So that's what I wanted you guys to be aware of regarding that vertical shift. So the second question says, explain why h does not have the x-intercept. Explain why h does not have the x-intercept. It's because we know that if here it was 0, we were going to have an equation of asymptote right there, and that would mean it was just going to rapala or sondela that broken line. But also in this case, it has shifted by 1 unit upward. So that means that is the reason why it will never have the x, what is it? The x-intercept. Why? Because it has shifted by 1 unit upward. By 1 unit upward, meaning it will just do that and get closer to that, but it will never cross. We know that it will never cross a that a asymptote, and it will never touch. So that means it will never intercept or touch the x-axis. So you can mathematically say because it has shifted upwards by 1 unit. Or you can say it's because the range is where y is greater than 0. So that means it is actually ranging above where y is bigger than 0. It is not going anywhere beyond less than 1. I'm not sure if that makes sense, guys, but this kind of reasoning, you normally get it when you've done a lot of math problems, and you tend to realize that, okay, it will never have or intercept with the x-axis because it has shifted upward. Does it make sense though? Hmm. Silence in court. I'm just not sure if it's because you guys are still thinking that side. But does it make sense, guys?
Yes, sir.
Okay, 100%. So now, let's quickly move on to the next question, which says, draw a sketch of H, clearly showing all the asymptotes, intercepts with the axis, and at least one point other, at least one other point on H. Yes, they want you to sketch to show the asymptotes, intercepts with the axis, and at least one other point on H. So with you understanding the impact of A and B and Q, you already have an idea of how your function is going to look like, which is what I'm going to try and explain there. To say, when you sketch an exponential type of a function, the first thing that you do, you start with that. That is your equation of asymptote. So you do it like that, where that is 1. So this is where y is equals to 1 at that point there. And then now, that's when you can try different values. This is what I normally do. If you remember, Leslie, I said when you sketch or when you plot this type of a function, you start from left to right. So it's either you start at the top going down like that, or you start from there going up like that. So I normally start, let's say, from negative 3, and then I'm going to try negative 2, then I go to negative 1, there is 0, then I'm going to plot 4, and then there I'm going to plot to 2, there I'm going to plot to 3. Just like our undercover has said, you just take your calculator and you plug. So it's going to be 4 into 2 to the exponent negative. You start with negative 3. So that means inside the brackets you say negative 3, you close, you go down, you close, then you say plus 1. So you need to punch this thing like this. You must punch 4 into 2 negative. Inside the brackets you start with negative 3, and then you do that. So you guys also have a problem of punching on a calculator and not punching it correctly. So that means inside you're going to do negative 3. What are you getting? I'm getting positive 33. So I can just assume that positive 33 is a point somewhere up there. And then now I'm going to edit that negative 3 and put negative 2. I'm getting 17. So I can just assume to say 17 is below that first value being 33. Then now I'm going to edit and go to negative 1. It's 9. I'm getting 9 where it's negative 1. So maybe 9 somewhere there. Can you guys already see that we are having that type of a decreasing shape? Then you go to 0. Then when you do 0, I think we know what it is. It's 5. So now this is where you are having your nice 5 there. Let's now go to 1. Let's now go to 1, and then if you say 1, you are having 3. Yes, let's see. Where that is 1, you are having 3. 3 maybe somewhere there. Let's go to 2. Where you are having x being 2, you also have that being 2. Let's go to 3 now. Maybe 3, it's giving us 1,5. So can you see? It now gets closer. If you increase those values, it will never be 1. It will just get closer to 1, but will never be 1. That is why what you do now is just to connect those dots there, and it gives you that very nice shape which will never touch and never cross. Make sure it doesn't. If it touch, they will give you wrong. So remember, they said also show another point other than this one where we know it is 5 there. You can maybe give that point. Do you remember that at this point, that's where x is 1 and y is 3 there? Otherwise, you can still give this one. I think that's where x is 2 and that is 2. You can also give this one if you remember, or you can give this one. I think that's where x is a -1 and that is 9. And here x, I think it's -2, and then y it's negative, no, y is 17 there. Yes. And then this one, I think it's what, where x is -33. I think it was 33 where x is 3. Yes. So you can either use that 1 point or that one or that one or that one or that one. It depends on you. And that's how you are going to score yourself 3 marks for that question. But wait, guys, did you see how I plot there? Does it make sense to everyone?
Yes, it does.
Last one to confirm.
Yes, sir.
Matapelo, can you see how important it is not to miss lessons? Because I think what we discussed today, it's a very important information of which it will help you during your exams. And those who missed today's lesson, they might struggle with this type of functions simply because they missed this lesson, and simply because they will be taught this at school, but they might not understand it the way you guys do. And what happens, Moleboge, is that if this type of a question comes in exam and the learner gets hammered, then it becomes questionable to say, but you're attending lessons and you're still getting hammered. Then whose problem is it, Moleboge? Would you blame me in this instance where this is explained and it's made easy?
No, I would not blame you because I would not have applied myself very well.
And imagine if you did not attend. The worst part is this lesson is done, it's going to be posted, and someone doesn't catch up, and this thing comes and they still get hammered. Because in your case, I would understand that because you've attended, at least you will score a mark somewhere, and also you will notice if you're making a mistake. You will know what to expect as you do calculations. But for someone who did not attend today, it's going to be a challenge, especially when they don't catch up. So this is me trying to say, always, if you miss a lesson, try to at least catch up so that you are not lost. Leslie, do you agree with me there, honorable member?
Yes, sir.
So now Quickly, let's wrap up our lesson for today by looking at that last question. So let's see. The last question says, describe the transformation from H to G if G of X is equals to 4, and then there we are having positive 2. Now, what is H? You need to remember that H is what you were given as H of X being equals to 4 into 2 to the exponent that close plus 1. So Leslie, what they are saying there is to say, what could have happened? This is you being a private investigator in real life, trying to analyze what could have happened. What transformation has actually taken place for us to move from this to that? That's what they are actually trying to ask there. And this is a tip that I'm going to give to you guys. If something is given like that, where it now has some brackets, try to work it out. Try to work it out and check how does this thing actually look like in its standard or general form. So it's more like I'm saying, try to convert this from that format to a format that we know, which doesn't have brackets. So that means G of X, it's actually the same as the ba the, meaning it's the same as 4 times 2 to the exponent negative x, or maybe let's put it inside the brackets. What is 4 times 2? Is it not 8? I think that is 8. So can you see, you've converted it from this format, which is something that we did not learn. You've converted it from that format to a format that we can interpret, where we know that, okay, this is A, and then we know B, it is actually 1 over 2 there. And then here we are having that. So between these two functions, do you guys notice the difference? Where does it differ between these two? Because that is where we know the transformation has happened. That is where the change was. Where has it changed?
The asymptote.
Asymptote 100%, or the Q value. So what do we know about the Q value? We know that the Q value, it's all about the vertical shift. And the vertical shift means up or down. So for this function of H, for it to shift from that to this, what really happened there? Did the asymptote shift upwards or downwards, and by how many units for it to end up being that? So if you remember the function that we drew previously, it was doing that at where y is 1, and it was also drawn like that. But you see, this one, if you had to draw for this one, it's still going to be the same, but this is what has changed. So the question is, what happened? Did the asymptote maybe shift downwards by whatever units or upwards by whatever units? What happened? That is what the examiner is asking there for 2 marks. What happened?
It
Shifted
shifted
upwards.
up by 7 values.
By how many units?
7 units.
Kancane liyavela bantu bakithi. Kancane. liyavela phindi undercover raskashala. That's one thing for sure. But kancane liyavela. Guys, that concludes our lesson for today. Meaning, you just say it has of course shifted upwards by 7 units. That's what happened, or that's what has transformed, where this function has shifted from that state to being that. So that means we now have that being there at where that is 8, and then it's going to do that. That's if you now draw this, it's going to do that. So that's all for today, Bantu Bakiti. Anyone who's got a question, or are we all on the same page? The Maakos uthulile that side. Are you with us, honorable member? I see
Yes, sir.
Vuyiswa is there also. Vuyiswa uthulile namhlanje. Kwenze njani? Are we together?
Yes, sir.
So,
Okay, so guys, thanks very much for joining. My name is Desmond. But before I sign out, I'm not sure what will be the code for today's lesson. I think today's freestyle. Let's make it freestyle Pantipagiti. Freestyle meaning whatever that comes to your mind, send in the group as you filling in attendance register. So the issue with attendance register Pantipagiti, it helps your parents to know which lessons you've attended, your attending frequency, and it also helps us to know, okay, this is the learner who attends most of our lessons. And during those times when we give you guys tests to write, when you struggle, we are able to notice that, okay, this learner, they do attend on a daily basis, but they still get lower marks. Then we are encouraged to then invest more time into proposing a one-on-one lesson where we check what could be the issue, and then we assist you. But obviously, if you don't attend, you will definitely get low marks. That's one thing for sure. So you are actually discouraging us to give you extra time based on the fact that you don't attend anywhere. And even if you do have an opportunity to catch up, you still don't catch up. It's not wrong not to attend, but make sure to catch up. Very, very much important, ladies and gentlemen. So, guys, freestyle. My name is Desmond. Have a very good night, and I'm out.